Asteroids, comets, and planetary defense. Are we ready for an impact event? Welcome back to the channel. Let's discuss some of the objects in space and planetary defense. Asteroids and comets. These ancient, celestial travelers may seem like distant cosmic curiosities, but they have played a defining role in the Earth's history and potentially its future. The very extinction of the dinosaurs, 66 million years ago, is attributed to a massive asteroid impact. Today, with our modern technological advancements, humanity has begun to understand the immense power these space rocks possess and what we can do to protect ourselves. Asteroids and comets. What's the difference? Though both are often lumped together, asteroids and comets are quite distinct. Asteroids are rocky, metallic bodies that mostly reside in the asteroid belt between Mars and Jupiter. They vary greatly in size, from small pebbles to objects hundreds of kilometers wide. Comets, on the other hand, are icy bodies that originate from much farther regions, like the Kuiper Belt and Oort cloud. When comets approach the Sun, their ice vaporizes, creating that iconic glowing tail. Both objects travel through space at incredible speeds. An asteroid just 1 kilometer wide, traveling at tens of thousands of kilometers per hour, has enough energy to wipe out an entire region or cause mass extinction. The history of impacts on Earth has always been a target. Our planet bears the scars of ancient impacts. Craters like the Chicxulub in Mexico or the Vredefort crater in South Africa stand as testaments to the destructive power of these celestial bodies. While massive impacts are rare, even smaller ones can be devastating. The 1908 Tunguska event in Siberia flattened over 2,000 square kilometers of forest, likely caused by a small asteroid or comet fragment. A more recent reminder came in 2013, when a meteor exploded over Chelyabinsk, Russia. Though it didn't impact the ground, the blast shattered windows and injured over 1,500 people. It was a stark wake-up call for scientists and governments alike, how we track near-Earth objects. NEOs. Today, space agencies around the world, NASA, ESA, and others are actively monitoring what we call near-Earth objects, or NEOs. These are asteroids or comets whose orbits bring them close to Earth. Projects like NASA's Planetary Defense Coordination Office and the Near-Earth Object Observations Program work with international partners to identify, track, and analyze these objects. Advanced telescopes, both on Earth and in space, constantly scan the sky for potential threats. When a new object is discovered, scientists analyze its trajectory and estimate the likelihood of it striking Earth. Though thousands of NEOs are known, many smaller objects remain undetected, which presents an ongoing challenge. Potential impact scenarios, from minor to catastrophic. Not all asteroids pose an equal threat. A small asteroid may burn up in the atmosphere, but larger ones could cause regional destruction or global catastrophe. Scientists often model various impact scenarios, from an asteroid crashing into the ocean causing tsunamis to one hitting a populated city. In worst-case scenarios, an asteroid several kilometers wide could trigger climate change, mass extinction, or even a collapse of civilization. It's not about fear-mongering, it's about being prepared. Planetary defense. The science of prevention. So what can we do? The answer lies in planetary defense strategies to detect, deter, or deflect an incoming object. These include kinetic impact, crashing a spacecraft into an asteroid to alter its course. NASA's START mission in 2022 proved this concept by successfully changing the orbit of the asteroid Dimorphos. Gravity tractor. A spacecraft could fly alongside an asteroid, using its gravitational pull to slowly tug the object off its collision path over time. Nuclear detonation. As a last resort, a nuclear device could be used to either destroy or redirect a dangerous object. Each method has pros and cons, and real-world success depends on how early we detect the threat. Time is the most important factor. The earlier we know, the more options we have. Global collaboration and preparedness. Planetary defense isn't just a scientific challenge, it's a geopolitical one. An asteroid doesn't care about borders, and any serious threat requires global coordination. Groups like the International Asteroid Warning Network (IAN) and the Space Mission Planning Advisory Group (SMPAG) have been formed to foster cooperation between nations. Additionally, simulation exercises where agencies simulate impact threats help test response strategies. These drills reveal the complexities of communicating with the public, coordinating evacuations, and deploying space missions under pressure. Public awareness and pop culture. Asteroids and comets have long captured the public's imagination. From Hollywood films like Armageddon and Don't Look Up to viral news stories of meteor sightings, the topic taps into both fear and fascination. But beyond the spectacle, it's crucial to engage the public with real science. Educational outreach and transparency about potential threats and ongoing research play a vital role. Public support is essential for funding planetary defense initiatives. Living with the risk. So, are we ready? The truth is we're getting there. We've made incredible strides in tracking and predicting potential threats. We've demonstrated the ability to deflect an asteroid. But there's still much to be done, especially identifying smaller objects and ensuring coordinated global responses. The cosmos is vast and unpredictable, but we are no longer powerless. With science, preparation, and unity, we can protect our planet from the ancient threat of space rocks. The story of planetary defense is still being written, and it's a story we all have a part in. As we look up at the night sky, filled with stars and mystery, it's reassuring to know that humanity is taking steps to safeguard our future, one rock at a time. Like, share and subscribe. Stay intrigued.